Okay, you should have already printed out the paper that looks like this, and so we're going to go through it together. So this is a section for geometry for 3-1, and we're looking at angles created by transversals. Okay, so starting out here, let's talk about what a transversal is. This line right here that goes down the middle is a transversal. It is a line that intersects two or more lines, other lines, at different points. So a line that intersects two or more lines at different points. So this is the transversal, and the other two lines are these two. And we see it intersects here, and the other one intersects here. So what happens is you get all these angles. You get 8 angles, 4 here from this line, 4 here from this line. Oops. I just wanted to erase some of it. Okay, so didn't want to erase everything. Okay, so what we're going to do is look at the angle relationships that are created doing this. Now, we already know some of the angle relationships, such as vertical angles are here, and linear pair are here. So for example, angle 1 and angle 4, those are vertical angles. So we're looking at more about the relationships between something like angle 1 and angle 5. So we're always going to have one angle in the top portion, or wherever it is, and another one in the other one. And so they're pairs of angles. Okay, so I'm going to recommend that you do this with colored pencils, markers, highlighters, something of that sort, because I'm going to color code everything. Okay, so let's go ahead and start off with the first type of angles. Our first type are called corresponding. Now if we think of the word corresponding, we kind of think like, well, this corresponds to this. This matches up with this. So I'm going to show you some corresponding angles here. Angle 1, which is this angle right here, corresponds to angle 5. So the way I think of it is you have two angles in the same position. Angle 1 and angle 5 are in the same position. This one's kind of top left, this one's top left. So for our first pair we have angle 1 and angle 5. Okay. Think about what other corresponding angles that we have here. Another pair would be angle 2. And which one do you think angle 2 goes with? If you said 6, that's correct. Angle 6. So angle 2 and angle 6 correspond to each other. They're both onto the sort of top right. So angle 2 and angle 6. Okay, let's keep going. Let's get a different color. Alright, so then we have angle 3 down here, which is sort of on the bottom left. That one goes with angle 7. So angle 3 and angle 7 correspond. This one's on like the bottom left and this one's on the bottom left. So angle 3 and angle 7. And last but not least, we have another pair of angle 4 and angle 8. And that gives you 4 pairs of corresponding angles. So how would we describe these angles? I would describe them as they are in the same position. So like I said, top right, top right. The 4 and the 8 are bottom right, bottom right. 3 and the 7 are bottom left, bottom left. Okay, next pair. I'm going to show you what they look like first, and then we will come up with a name second. So starting with angle 3, and then the other one is going to be angle 6. So 3 and 6. Well, think about how we would describe them. Well, they're on different sides of our transversal here. So because they're on different sides of the transversal, we say they are alternate, because they're alternating sides of the transversal. And then the other part of this is they're kind of inside the two lines. You see that? So this is the interior of the two lines. So they're called alternate interior. So what other pair do you see? The other pair we see is 4 and 5. And so again, they're alternating sides. They switch sides of the transversal, but they're still interior. They're still inside. So because 1, 2, 7, and 8 are on the outside, we're not going to use those for these. So that's why there's only 2 pairs. So how would we describe them? They are alternating sides of the transversal, and are inside the two lines. Okay. Similar to that, we have alternate exterior. So now that we know what alternate interior is, alternate exterior is very similar. So let's start with an exterior. Well, let's talk about what the exterior is. If this is the interior, then the exterior is here and here. So we need to look at angles that are on the exterior. But again, we're alternating. So let's see, highlighter, angle 1 is an angle on the outside, and if we ignore all the inside and we go to the opposite side of the transversal, we have angle 8. So there's our first pair, angle 1 and angle 8. What would the other pair be? The other pair is going to be 2 and 7. Again, they're on the outside of the two lines and they're flip-flopping. So they're on the opposite sides of the exterior, or the transversal. So angle 2 and 7. So how do we describe them? They are alternating, just like before, sides of the transversal. And they are on the outside of the two lines. Okay, next, last one here. Now the last one here is going to have 2 different names. One is consecutive interior, and the other name is same side interior. So we know by the word interior they're going to be on the inside here. So we're just looking here. But instead of alternating, they are on the same side of the transversal. So let's start with 3. So 3 would go with 5. So I didn't go onto the opposite side of the transversal this time. So 3 and 5 is one pair. Okay, different color. Next pair would be 4 and 6. Now there is such a thing as consecutive exterior or same side exterior, but your book doesn't go into it. In fact, your book doesn't even go into the alternate exterior, but it totally exists. Okay, so how would you describe them? They are on the same side, hence the name, of the transversal. Consecutive is a word that is another way of saying same side. And they are inside of the two lines. Okay, so I'm going to switch over to GeoGebra to show you something. Okay, so this is GeoGebra. So I don't know if you can see the whole thing. You're probably only going to see part of it, but I think you'll be able to see most of it. Okay, so then I'm going to draw some lines. So I'm going to have that be my transversal. And then here's one of the lines going through it. And here's another. So then I'm going to get the point of intersection between these two lines. So I highlight this, and I get point G. Highlight this, and point H. Okay, so I'm going to measure a couple of, let's see, some corresponding angles. So I'm going to measure this angle right here. So you can see that it's 33.54 degrees. That's this little angle right here. So corresponding to that would be this angle down here. So A, H, E. Okay, you see I did it wrong. I needed to start with E, then go to H, then go to A. Okay, so right now the measurement of this angle, I can move this a little bit. It's 43.14 degrees. So right now, nothing fantastic about them, but I want to know when would they be congruent. So think about that. What situation would have to happen for these two angles to be the same measurement? So right now they're 10 degrees apart about. Well, it has something to do with these two lines and how they look. So right now they're kind of just a couple of lines. But I'm going to move F around a little bit, and I'm going to try and change this angle so that it'll become the same as 33.54. Okay, so I see if I go this way, it gets much bigger, and I don't want that to happen. In fact, if I go past A, it gets all messed up, so let's not do that. Okay, but if I go this way, it gets smaller, but that's too small. So let's find a happy medium. Let's find 33.54. So I got 33.14, which is really close. 33.36. Okay, so it's a little hard to get exact when I'm trying to do this. So I'm going to stop there. I want you to look at the lines. What do you think is true, or getting close to being true, because it's not exact, about these two lines? So this line and this line. Well, they're going the same direction, right? And the word that we have in geometry for if they're going the same direction would be parallel. So if I were to scratch this whole thing, go open, new, don't save, and just start over. This time I'm gonna make my transversal, and I'm gonna make a line. But this time I'm gonna make a parallel line. Pick a point, and I'm gonna pick this line that goes through that point. Okay. Move this B a little. So then I have some intersection points. Let me just get my intersection points. And let's measure some angles. And let's see if it actually worked, if I did get a perfectly congruent angle. Okay, 129.57 right there. So I'm doing the top left this time. It doesn't matter. In order to measure this angle down here, I need another point. So I'm going to pick a point H that's on this line. Okay, so now I'm going to measure this angle, FGH. And look at that. 129.57, 129.57 on the dot. Now, if this was really true, I could mess up these lines as long as they're still parallel, and the angles would still be congruent. So the way that it's constructed is the lines are parallel. So I'm going to move C, and then notice it when I move C, it moves the other line. And also notice what happens to the angles. 142.2, 142.2. It doesn't matter. Okay, if I move D, same thing. Okay, and now let's just measure the rest of these angles. This angle right here I know should be exactly the same as 125.42 because they're vertical to each other. Oh, I measured it the wrong way. GFD, 125.42. And then down here, A, G, E, 125.42. So all of these angles are congruent to each other. And if I move like E, or point D, they're always going to be congruent to each other. So that means corresponding angles are congruent, but then the alternate interior angles, like this one and this one, are alternate interior, and alternate exterior are congruent. But what about these other four angles? Well, if you measure those, that gives me 57.68. Okay, now I'm going to measure, now I'm going to measure E, G, F. That's 57.68. Oops, where'd the other one go? Now, by vertical angles, that means this one's going to be 57.68. Went the wrong way. It's a little hard to see, but it's in there, 57.68. And then let's measure the last one here. Getting lots of angles here, but there's 57.68. Now, if you think about it, what's 122.32 plus 57.68? It's 180 degrees, as it should be, because these two angles here are supplementary. And if I were to move D around, those four angles, 43.68, 43.68, 43.68, 43.68, those are all going to be congruent to each other. Okay, so on your notes, let's go back to the notes. We get these. These are pretty much the theorems I was just showing you. The first one, first one's a postulate. The corresponding angles postulate. It says if a transversal intersects two parallel lines, so these marks right here mean parallel, then corresponding angles congruent. So angle 1 and angle 2 are corresponding angles. They would be congruent to each other. Okay, then we have theorem 3.1, alternate interior angles theorem. which says if a transversal intersects two parallel lines, that's key. So we can see line A and B are parallel here. Then alternate interior angles are congruent. So alternate interior angles here would be 1 and 3. And then you have something called the same side interior angles theorem, which says if a transversal intersects two parallel lines, then same side interior angles are supplementary. And so what we saw was, like, if this is 100, this is 100. But since 3 and 2 were supplementary, that would be 80. That makes these supplementary. 80 plus 100 is 180. Okay, so angle 2 and angle 1 will add up to 180. So they're not congruent. Same side interior angles are supplementary. Okay, so the rest of these are examples where you're solving for x using what we just learned. So let's look at first one. First, think about do you have parallel lines? Yes, we do. Next, think about what kind of angles do you have? Well, this one's on the top left, and this one is on the top left, so they're corresponding. So corresponding are going to be congruent. In fact, the way that I kind of just do it is I just sort of think of it as, okay, this one, this one, this one, and this one are all going to be the same measure. Then this one, this one, this one, and this one are all going to be the same measure. So if they're the same color, I set them equal to each other. They're congruent. If they're different colors, they're supplementary. That's pretty much how you can do it. Sums up the whole thing. Okay, but in this case they're congruent because they're corresponding. So when they're congruent, you set them equal. So 120 equals 11x plus 10. Now I just solve for x. So I subtract 10. 110 equals 11x. Divide by 11. X is 10. So if I were to plug that 10 back in here, that'd be 11 times 10 plus 10. That's 110 plus 10 is 120. It should give me exactly the same. Alright, let's look at number 2. You can do that trick I just showed you where you color it. It's almost like a checkerboard pattern. Congruent to this, congruent to this. And then I pick a different color and I go, these are congruent, these are congruent. So if they're the same color, congruent. If they're different colors, supplementary. Okay, but here I have 10x and this, which is a 90-degree angle. That little box means it's a right angle. These are alternate exterior angles. So 10x equals 90. And we know because alternate exterior angles are congruent. Even though we didn't have a theorem for alternate exterior, it's pretty much the same. They're congruent. So then divide by 10. X is 9. Okay, moving on. This one's a good example because it shows you that you can do the same thing with 3 parallel lines. It doesn't matter how many parallel lines you're looking at. So for example, if you just focus on the lines that we need, which are this one, and this is the transversal, these angles here are alternate interior. And so they would be congruent. But again, you can do that trick where these two are congruent because they're vertical, and then you just match the same positions up because corresponding angles are congruent, and then do the other pair. So then that would be, or other group. It makes a pattern. So ours are going to be congruent again. So 7x minus 6 equals 50. Add 6, 7x equals 56, divide by 7, x is 8. Now, a lot of these you set them equal to each other because they're congruent, but not all the time. In this case, if you look here, if we do the highlighting thing, this one will be congruent to this one will be congruent to this one. Choose a different color. Alright, you get the pattern going, and you'll see 130 is not the same color as x plus 58. These are same side interior angles, which means they're supplementary, which means, you should know this, that they add up to 180 degrees. So that's how we're going to set this up. One of the angles plus the other equals 180. So just 130 plus x plus 58 equals 180. And then we just solve for x. So let's combine our like terms. That's going to be 188. Subtract 188. And if you're freaking out right now because we're getting a negative, that's okay. The variable can be negative, the angle cannot. If we plug the negative 8 back in, you get negative 8 plus 58, which is 50 degrees, which is positive. And that makes sense. If this is 130, then that's 50 degrees. Alright, that's the end of this video. Make sure we'll put these notes in your book when you get your book back.